Okay. So far we have what do we have? We've got a power rule is what we started with. I'm just going to give you like kind of the overview of what we've done so far. We've got the power rule. We've got product and quotient. Okay, and the chain rule is going to be, it's going to use the power rule, but it's not just one term anymore. So when we did the power rule, our base was typically just an x. Our base was never a polynomial like it is right away in this first example. So when we had the power rule of, let's say, x to the fourth power, we just made the derivative 4x cubed. That was because our base was just an x. Now our base is a polynomial in and of itself, or a, you know, and we'll see if it's always a polynomial. I guess it does seem to be. So we're still going to start with the power rule, meaning we're going to take our 4, put it out in front, keep our base the same, and drop the 4 down to a 3. But then we're going to multiply that by the derivative of what's inside. And what I mean by that is the derivative of the base. Okay? So the base here being x squared minus 5, what is the derivative of that? Just 2x. Good. So this is your f prime of x. That's your derivative. Now we would clean that up just a little bit. The 4 can be multiplied by the 2x to make 8x. But we're not going to cube out anything. That would be pretty ugly. And again, if there are other ways to do this problem, we could get that same derivative answer. It would probably look different from this form. But if you ever did multiply x squared minus 5 by itself 4 times, and you kind of stretch that all out into one big polynomial and then found the derivative just by using the power rule, you would get this answer. You would get the same thing. Once you cube this out and distribute your 8x, you'd see that it was the same thing. But that's the chain rule. You're really following the power rule, and then you're multiplying it by the derivative of what's inside. So go back to this example here. Technically our base is x. We've sort of, you could argue that we've been doing the chain rule, we just haven't had to think about it. So we bring the 4 out in front, so making it 4x cubed, and you multiply by the derivative of your base. And what's the derivative of x? 1. So multiplying it by the derivative of what's inside, in other words, the derivative of the base is 1, and so you still get 4x cubed. So you could argue that we've been doing it. It's just we haven't had to think about it, and you haven't been, your attention hasn't been called to the fact that our bases have all been x's. We haven't had to worry about our base being a different polynomial. Does that make sense? Easy enough? Okay. So jumping down to the next example with this square root of 5 minus 3x, I would still get in the habit of rewriting your original function into a more conducive format to the power rule. So when we initially go to find g prime, we follow, thank you, Ray. We follow the power rule first, bring your 1/2 out in front, keep your base the same, reduce your power by 1, so that's going to be negative 1/2. And then we're going to have to multiply this by the derivative of what's inside, or the derivative of your base, which is what? Negative 3. Okay, so cleaning this up, the negative 3 times 1/2 makes negative 3 over 2. And then the 5 minus 3x that's being raised to the negative 1/2 needs to be brought to the denominator. and brought to the positive 1/2 power, aka taking the square root of it. I don't think you'll see this rationalized. I think that would be the final answer, but in the event that, just to be aware that it's a possibility, if we wanted to rationalize, we could. I'm just going to go that way and distribute my 2 on the denominator. But I'm thinking that that's probably going to be your answer. Any questions with that? All right. Why don't you take a minute and try this one on your own? Raise your hand if you're done. Owen, can I steal yours? You feel confident? You feel confident. Alright, I'm gonna show Owen's here. And the first thing Owen did was just rewrite it, right? So I'm just gonna be clear that that's still the original, right? And it wasn't until here that you started finding the derivative. Just to be clear, because the way you had it made it look like this was equal to this, but now we've switched gears. So here's our derivative. So he's taking his 1/4 out in front with a -3, gets -3/4. Good. The 2 minus 9x stays, and 1/4 reduced by 1 is -3/4. And he's multiplying it by the derivative of what's inside, so -9. That's your derivative of this piece. Great. So then -9 times -3 is 27/4. And at the same time, he's bringing this 2 minus 9x down to the denominator and taking the 4th root of that cubed, just to change his 3/4 power. So that's good, I think. Any issue with that? Questions? Comment? I'm just doing it a little bit darker so it can be seen. Oh, maybe I gotta get rid of this and rewrite over it. So 4 times the cubed root of 2 minus 9x, 4th root, yep, thank you, cubed. There, that's better. Any questions on that? Okay, try the next one on your own. While you're doing that, I'm going to pass back your derivative quizzes. These will not have corrections. Just FYI. The test corrections are due tomorrow, yes.
Are you at the
I'm not. I'll be here before school tomorrow. They're due at class 10. just saying, we should make sure we're not twiddling my thumbs.
Good thing to see.
I'm just kidding.
How much was the one for
I'm just trying to think, yeah. It was out of 30 points, that quiz I just handed back. So, if you got like 4 off, calculate 26 out of 30. Raise your hand if you're done with this next example. Jess, can I steal yours? See how we do here. Alright, so, good. Jess is nice and organized. She first rewrote the original function by bringing her t plus 3 to the negative third power out in front, and then she's going to start the derivative. So she brings her negative 3 out in front, making that a 15 times t plus 3 to the negative fourth, times the derivative of what's inside, which just happened to be 1, and then she brings her t plus 3 to the negative fourth power down to the denominator. Perfect. Any questions on that? Would you look at that, she also went ahead and did this one. This one's trickier. Why?
I have no idea. Did she do something wrong?
So she went ahead and she started following the power rule. She brought her 3 out in front. She got 3x minus 9 squared times the derivative of what's inside, but it's not right. No. No. It's because this out here in front is not a constant. Okay? This is going to require the product rule. Here's your first term, and this 3x minus 9 to the third power is your second term. So in every other case, our coefficient has either been a constant, which is fine, but when it's another variable, now it's the product rule is also in there. So when I start the product rule, I need to do the first times the derivative of the second. Now the derivative of the second, and here's the second piece, here's the first piece. The derivative of the second is going to take the chain rule within it. So it's a chain rule within the product rule. So here's your first times your derivative of the second. So that's going to be bringing a 3 down, leaving your 3x minus 9 squared times the derivative of what's inside, 3. So that's your first. And this here was the derivative of your second. And that, in parentheses, I'll put chain, because that derivative of your second required the chain rule. Plus your second times the derivative of your first, which is, what's the derivative of x? 1. And so cleaning this first section up, we have a 3 times a 3 times an x. So that's going to make a 9x times 3x minus 9 squared plus 3x minus 9 cubed. And how might we go a little bit further with this? Aaron?
You could factor out a 3x minus 9 squared.
Right, both terms of our binomial have a 3x minus 9 squared. So if I factor that out in front, I'm left with 9x from the first piece, plus a 3x minus 9, because you took 2 of the 3 of those, so you still have 1 left. And then within that second set of parentheses, obviously, we can factor, or combine like terms, rather. We get 12x minus 9. I was looking ahead a little bit because that 12x minus 9, we can obviously pull out a 3 from that. So I put that out in front. Why can't I pull one of these 3's out in front as well? From 3x minus 9. Because it's square. If anything, and I don't think I would do this because it would make it look ugly, if anything, I would have to do this. But that doesn't look very nice, right? But I could, because when I square this, I'm just going to have to square the 3 and square the x minus 3. What's going to happen when I square the 3? It is going to be a 9. So that 3 here could be multiplied by this 3 squared, which is going to be 9. 3 times 9 would be 27. And then you would just have x minus 3 squared and 4x minus 3. That would be the cleanest version of this. So I did sort of factor that 3 out, but I didn't take that 3 and put it out in front because it's out in front of something that's being squared. And then I treated that 3 squared like a 9 times 3, 27. Okay? Any questions? All right, onward. What are our thoughts on this one? That being our division symbol, just make it a little longer. Okay, make it to the denominator, x to the 4th plus 4 to the 1/2 power. Okay. What rules do we need, though, to get this derivative started? Quotient. Okay? So it's going to be a quotient rule problem with a chain rule wrapped inside of it. Okay, so, yep, Aaron?
Would it be possible, could you bring it up to the numerator by making the exponent like a negative?
Mm-hmm.
And then could you do the product rule?
And then you could do the product rule with the chain rule wrapped up in it. Either one. Why don't you, Aaron, go ahead and do it that way. I'll do it with the quotient rule and see kind of, then we'll match them side by side and see how they end up. And then everybody else just choose whichever one you want. I'm going to do the quotient. So that's my bottom. Times the derivative of the top. And the derivative of the top is just 1, so I'm not even going to write that. Minus the top times the derivative of the bottom. So that's going to require the power and chain. So this times 4x cubed here is my multiplying by the derivative of what's inside, so the derivative of x to the 4th plus 4. So this whole thing was the derivative of the bottom using the chain. And then this would be all over bottom squared. And then cleaning up. So I'm going to put this back to a radical. I'm going to move this to the denominator. The denominator within the numerator, obviously. This 4x cubed times x times a half can all become 2x to the 4th. So I'm really multiplying this times this times this. Those are all your monomial coefficients. So that's going to be 2x to the 4th over the square root of that. And then we're all over, when I take this power to power, multiply a half times 2, you just get 1, so there is no exponent. The denominator is just x to the 4th plus 4. So it's cleaner, but still we have complex fractions and we've got radicals in denominator. So I'm going to get a common denominator up here by multiplying by root x to the 4th plus 4, which is going to work out nicely on my numerator here. So that's just going to become x to the 4th plus 4 minus 2x to the 4th over my denominator. So that would be maybe me keeping the numerator, and then rather than dividing by this, I would keep change flip. If I combine my terms here, I get negative x to the 4th plus 4 over the square root of x to the 4th plus 4 times x to the 4th plus 4. And it's so tempting to want to cancel that x to the 4th plus 4, but I don't think it's working out unless I did something wrong. The only thing I might do from here is rationalize, but that's not going to really do much for me either. These two? Because they're not the same. They both have a positive 4, but this is a negative x to the 4th, and so that would be like trying to cancel x minus 3 and negative x minus 3. Owen suggested make it negative 1, but he's confusing it with that rule. That you could cancel and make negative 1. But that's not the same thing. You see the difference with those simpler examples? So Aaron, how does ours look compared to yours?
Pretty much the same. I just for the bottom, I made it so it's like x to the 4th
Sec-
As,
Okay,
if you can add
yeah,
that.
yeah. Because this is to the 1/2 and this is to the first power, so you kind of have common bases. So you put it to the 3/2 power. But we did get the same answer
Yeah.
when you did the product rule way. Good.
So the product rule is easier.
Was it easier, did you feel, because you didn't have a denominator complex fractions wrapped up in it?
Yeah.
Yeah, it might be. You have a little more negative exponents that you have to deal with, so I guess you just have to pick whatever for you is the lesser of two evils. But complex fractions is the ugly part of this one, and the negative exponents are going to be the ugly part of the product rule. Good stuff. Any questions? The derivative, agree with me or maybe disagree. I don't think the derivative stuff is the hard part. It's the cleanup
Yeah.
and the algebra that you have to be neat about. So on our multiple choice assessments, we'll make sure we use separate sheet of paper, because you don't want to try to cram this in. You're bound to make a mistake. It's not cleaned up. All right. What's our plan of attack here? This one was the quotient rule, the way I did it anyway. The quotient rule with the chain wrapped up in it. This is the flip of that. This is the chain rule first, because the whole base is being squared. So we're going to follow the chain rule first, power chain, so bringing that 2 out in front. And then when we go to multiply by the derivative of what's inside, that's where our quotient rule is going to come into play. You follow the organization of that? It's not order of operations, but it's kind of the order of what derivative rules have to come first based on the structure. When we look at those two side by side, do we see why this one is first, the quotient, followed by a chain rule within it, whereas this one's the chain rule first, followed by the quotient rule within it? That's a key piece here. So our power rule, again, brought that 2 out in front, leaves the base the same, drops the exponent technically down to a 1, times the derivative of what's inside. So this is going to be a big parenthesis set of the quotient rule. We have our bottom times the derivative of the top, 2t, minus our top, t squared, times the derivative of the bottom, 3t squared, all over the bottom squared. I'm going to clean up this numerator first, I think. I'll worry about the rest of this later. So I'm going to keep that all the same for now. And when I distribute here, I'm going to get 2t to the 4th plus 4t minus 3t to the 4th. And then I can, nicely enough, combine this. 2t to the 4th minus 3t to the 4th is negative t to the 4th. I can put this 2 over 1. And now just multiply across that numerator. So this 2t squared is essentially being distributed here. Agreed? Yes? So 2t squared times negative t to the 4th is negative 2t to the 6th. And 2t squared times 4t is positive 8t to the 3rd. What's our denominator? Yeah, t to the third power plus 2 cubed, because you've got one of those binomials multiplied by 2 more of the same binomial, so it's just that binomial cubed. And then I actually am going to factor out my numerator. I'm going to factor out a negative 2t to the third. That leaves me with t to the third minus 4. If I got lucky, it would have been a t to the third plus 2, so I could cancel it, but that's it. Any questions? Okay. Next example, what rule are we going to apply first, followed by what rule are we going to have to follow within it? Chain first, followed by the quotient. Very good. So, and when you say chain, you're really saying the power rule. It's actually almost 3. It's like the power rule, which has to require the chain rule because our base is more than just an x, followed by the quotient. I do the same. I kind of say chain and I mean power / chain. So we bring our 3 out in front. Keep your fraction untouched. Drop your 3 down to a 2. Times the derivative of what's inside, so this is the chain rule, but the derivative of what's inside requires the quotient. So a nice large set of parentheses. For our bottom, times the derivative of the top, which is just 6x, minus our top, times the derivative of our bottom, which is just 2, all over bottom squared. And again, I'm going to clean up the quotient rule portion of this first. And this is where I know a lot of you hate to rewrite this section, and you start doing work just on this. But then we lose some things, our organization lacks, and then we drop things by accident. So I know it's obnoxious, but keep it clean, keep it consistent, and suck it up and rewrite the stuff that you're not touching necessarily right yet. When I distribute over here, I'm going to get 12x squared plus 18x. And right here, I'm technically distributing a negative 2 to this binomial. This negative and this 2. So that'll be a negative 6x squared plus 4. So this numerator is going to become a 6x squared plus 18x plus 4. And then I think I might try to factor this. I can definitely pull out a 2. And then is that factorable? Is 3x squared plus 9x plus 2 factorable? No. So, here's my, getting closer to my final answer. I have a 3 up top times a 2 up top, which is going to make 6. That covers those two. Remember, this whole set of parentheses is being squared. So this numerator is squared, and this denominator is also squared. You with me there because of that? So then the next piece of my numerator is going to be this 3x squared minus 2 squared, followed by the trinomial that was not factorable. Well, that's my numerator. And my denominator is what? Not cubed. We just missed out on, it's the 2x plus 3 squared and the 2x plus 3 squared, which is going to make 2x plus 3 to the 4th. Good morning, what's up?
I didn't mean to barge in. I just wanted to know if we were going to meet today.
What do you have next period? I'll come find you. Have to look.
Study hall.
Oh, good. Where? What room do you know?
107.
Okay, I'll come find you and I'll talk to you about it then. Okay? Thank you. Alright. So that was ugly. But I think that's as far as we can go. Any ideas how we can go anywhere else? Nothing's factorable, everything's factored. Are you looking forward to tonight's homework? And we're not going to get through this one, but what's our plan of attack? What rule should we apply first? Good, Dan. The product. I would probably rewrite this, so in saying the product, that's kind of the first, and this 16 minus x squared to the 1/2 power is the second. Yes? Okay. So you're going to follow the product rule, doing your first times your derivative of the second. But what's the derivative of the second going to require? Chain, exactly. So it's the product rule first, and then you'll have to do the chain within it. So first times derivative of the second, plus your second times derivative of the first. Actually might not be so bad. But again, the cleanup will be the hardest part. So your homework is there at the bottom. You know your test corrections are due tomorrow, right? What else? Yeah. So anybody who's absent can go online and watch it.
When I was watching the video last night, it was like 6th period, I think, and they had the same question, like, when you talk about.
Alright, so there's your chain rule.